apply regression analysis class. Of course, today I want us to finish the outstanding in the material that we started on Monday. Of course, I introduced you to variable selection on Monday. And of course, I'm going to start from where we left off. But for me to quickly have a recap on what we started on Monday, this is about deciding how to select variables into our model. I think I remember I mentioned something that has to do with a way of improving the ordinary least squared. And I also identify that in addition to assumptions underlying the use of ordinary least squared, there's also another possibility, that may make the ordinary least square to behave badly in addition to assumptions. And I remember I mentioned a situation where the number of features, the numbers of explanatory variables, if it is more than the number of observation, of course, there's going to be issue using the OLS, and we actually propose some solutions, on how to deal with that. I remember we talked about using the idea of a shrinkage that involve a lasso and the ridge. Then we also talk about using the principal component analysis. We also talk about using a variable selection approach that we call the stepwise. And of course, I remember I mentioned that if you want to, if you're into model building, we have criteria that we normally put into consideration. There's a criteria that we call model fitness, the one that has to do with model fitness, and we have criteria that has to do with the model complexity. And of course, I remember I mentioned what do we mean by model fitness? Of course, I said that's a measure of how the model you use fits your data. Okay. How the model, if you want to have a measure of how the model you use fits your data, that's actually called model fitness. But situation where you got a lot of features, you got too many independent variable, explanatory variables that we also call predators in your model. Of course, you cannot rely on the criteria of model fitness. So you need something more. So in that situation, of course, you need to put into consideration model fitness and model complexity. When I talk about model complexity, I'm actually talking about, okay, I want to have a measure of how flexible or how sophisticated is my model. How flexible in terms of maybe I'm interested in the number of non-linearity it can capture or the numbers of parameters. And if I'm talking about model fitness, we have to measure. I remember I mentioned R squared and the residual sum of squared. So R squared and the residual sum of squared, they are the only metric of evaluation when you are interested in model fitness. Okay, but situation where you also want to put into consideration the complexity due to the number of explanatory variables you have in your model. Of course, you need beyond model fitness. You need both model fitness and model complexity because you want a situation whereby the model will fit your data and at the same time, you need some flexibility in the model, okay? Because depending on the situation, of course, you want a model that can actually adjust to any given situation. And the criteria for model fitness and model complexity, of course, I remember I gave you what I call the AIC, the BIC, and the adjusted R square. Okay, so when you're talking about the model selection criteria, I want to select the best model. And of course, for you to be able to do that, you need to consider what I call the model fitness and model complexity criteria in doing so. And what are the model, what are these criteria? Of course, the adjusted R squared and the Akake information and the Bayesian information. So the model with the largest value of adjusted R square is the most trusted model. And the model with the smallest AIC or smallest BIC also the best model. And let me say this, at times there are situations where these three criteria may be in conflict. I'm going to say that again. There is possibility that, using these three criteria, there could be some kind of conflict where they may not agree at times, but in most of the time, they agree. Okay, so I think I showed you in the last lecture the formula for adjusted R squared. I showed you the AIC, and of course, I also show you the BIC. But you know what? What is new? What do we want to talk about? I want us to go into an example. And you know what? In this example, because of the fact that we have a good numbers of for instance, if you take a look at, I'm looking at the effects of experience on this, the salary of a professional workers. And you know what I did? I actually fitted different models. I needed to pay attention. Okay, pay attention to this. You know, I fitted all this model, but I'm looking for the best among them. The first one that I fitted is actually a simple linear regression. The second one that I fitted is a polynomial of degree 2. The third one that I fitted is polynomial of degree 3. And the fourth one that I fitted is polynomial of degree 4. And what I did after, estimating the parameters in all this model, I actually, I want to compare different criteria. And what are the criteria that I want to compare? I actually want to compare the criteria that has to do with the model fitness and model complexity. Why why do I have to use that? Why not just the criteria for model fitness? Of course, the criteria for model fitness is not going to be appropriate here because if you take a look at the high degree polynomial that I have, okay, there's a complexity. If you take a look at that, and using just the RSS or the R squared is actually going to mislead here. So I need something more. And that is why I actually want to use the AIC. I want to use the BIC or the adjusted R square. If you take a look at the AIC, please pay attention. I said the model with the smallest AIC is the best. Now, when you take a look at this, the one with the smallest is actually uh, the quadratic. I think you can see 299.2, right? The AIC choose quadratic. Let's see what the BIC is actually choosing. I think the BIC, if I'm not mistaken, the BIC also choose quadratic. But let's see what the adjusted R square is going to choose. Adjusted R square choose cubic. 0.9241. Don't forget I said the model with the largest value of adjusted R square is the best model, but using the AIC and the BIC, the model with the smallest value of AIC and the BIC is the smallest. But right now there's a conflict. But the AIC and BIC choose the same model, but the adjusted out square choose another model. But you know what? In a situation where there's a disagreement like this is more or less like having a three judges in a particular court, and we ask them to vote similar to what is done in a Supreme Court of any country, or where the majority carry the vote. So right now we're actually going to settle for you know the AIC, the one by the AIC and the one by the BIC. Even if you look at the adjusted house square for the one or for the model chosen by the AIC and the BIC, you're actually going to see there's no significant difference between this guy and this guy. So because of that, we're actually going to go with that. Okay, so like I said, now you've now seen the criteria that we can use in selecting model, where I run different models. And I want to go into selection method. Selection method is different from criteria, selection criteria. I'm going to say that again. Selection method is different from selection criteria. Okay, the selection criteria here, the AIC, the BIC, and the adjusted out square. But right now, I want to talk about, I want to put into consideration the method of selection. Okay, I got two method of selection here that I want to consider. All subset selection and the stepwise selection. Okay, all subset selection and the stepwise selection. Let me tell you, when I talk about all subset selection, okay, that is more or less telling me that probably I actually want to run through all modules, and of course, I'm going to actually use the subset of that. But the stepwise selection is going to say I'm actually going to go sequentially the that's why it's called stepwise. Okay, I can choose to go by forward selection. I can choose to go by backward elimination. I can choose to go by both direction. But you know what? I need you to pay attention now. I actually want to walk you through the off subset selection. I want you to see all subset selection. Now I want you to see stepwise selection. Now, right now, we want to focus on the method of selection. Now, I need you to pay attention. Let's say, for instance, I'm actually want to fit a model and I have three predators. But the bottom line is, I don't know whether I should use all the three predators. I don't know whether I should use one predator at a time. I don't know whether I should use two. I don't know whether I should use three. I don't even know whether I should use zero predator, because using zero predator is using an intercept model. Now I need you to pay attention. I want you to see how this is going to work. I got three predators, okay, which is exactly what you're seeing here, okay. This the most simplest form of model I can actually back upon having three predators is when I don't use any of them, which is this guy, okay. There's a guy. That guy is actually the simplest form of a model that we call the intercept model. But you know what? With all subset selection, I'm actually going to use the idea of, the subset in a set theory in mathematics. Let me tell you this. It's not as if statistics is difficult. When statistics is difficult, what is difficult is math. If you understand your math, you understand statistics so well. So right now we want to borrow the idea from mathematical theory that has to do with a subset. Now, I remember, if you want to talk about, if I have a set, okay, if I have a set, okay, maybe I have a set with 3 elements. Please pay attention. If I have a set with three elements, A, B, C, and I want to figure out the proper, the proper subset, like I want to figure out what is the possible number of subsets that I can have in this set, the possible number of subsets that I'm actually want to have in a set. Okay. And let me tell you this. I can have A, I can have set A, I can have B, I can have C, I can have AB, I can have BC, I can even have ABC. Then I can also have empty sets. How many do I have? One, two, three, four, five, six. Okay. So I think there's another one, AC. Yeah. Now when you take a look at that, one, two, three, four, five, six, seven, eight, which means the formula is okay, 2 raised to power 3. Okay, what is 2 raised to power 3? That's actually going to be 8. That is a possible number of subsets. But you know what? We want to hide under this idea. Okay, and we have 3 predators. In mathematical theory, we have 3 elements in a set, right? And we said it's going to be 2 raised to power 3 to figure out the power of a set. The power of a set is the possible number of subsets we have in a set. And of course, from the formula, it's going to be 2 raised to power cardinality of a set. That was why I said 2 raised to power 3. The cardinality of a set means the number of elements in a set. In this set, I have 3. The power of a set is going to be 2 raised to power 3. I'm actually going to have 8. We now want to use this method now in statistics. We want to use this method in all subset selection where I got 3 predators. Okay. Now let's take a look at what we're going to have. Pay attention. I'm going to have the first one. This is looking like an empty set. The first one here is actually, I'm talking about when I don't use any predator at all. The next one is when I use one predator at a time. How many do I have? 3 here. When I use one predator at a time. Another one is when I use 2 predator at a time. And the last one when I use 3 predator. Let us count the numbers of module now. 1, 2, 3, 4, 5, 6, 7, 8. So which is synonymous with the fundamental theory of sets, of sets, where you talk about the proper, you talk about figuring out the number of subsets that you have in a set. Okay. Now, if you take a look at this is a possibility. Okay. So which means if you want to decide, okay, when you say all subset selection, you actually going to fit all modules. And after fitting all module, you will now decide using the criteria of module selection, which module has the lowest CIC, or which module has the lowest BIC, or which module has the largest adjusted R squared. But you know what? This is going to take forever in a situation where you have a lot of predators. I have 3 predators right now, and I'm actually going to fit 8 modules to decide the best. What if in a situation where I got 10 predators? That would be 2 raised to power 10. There's going to be a lot of modules. And that was why I said, what is the strength here? The strength of all subset selection is that it's actually going to give you opportunity to go through all possible modules before you arrive at the base. But the weakness is it's computationally expensive. It's going to waste your time before you are able to arrive at that. Is there any question before I move to another method of module selection? I want to go away from all subset selection now. Is there any question? Okay, so if you're good, I want to go to the next one. Please pay attention. You know what I put here before going there is that the moment the number of regressors increases or the numbers of predator increases, the numbers of model will increase exponentially. That's exactly what I mean. Okay, so you know what? I want to go into stepwise, which is another method of selection. You know, I told you something the other time because of the limitation of an approach. This is the reason why we have alternative approach. We don't just do what we do. There's a reason why we do what we do. There's a reason why we go from one approach to the other. We're actually going from one approach to the other because probably there's a limitation. Of course, when you take a look at the all subset selection, okay, that is actually going to waste my time if I have a lot of modules, because of course I'm going to have a lot of modules if the numbers of regressors is large. But because of that, I'm going to consider a stepwise selection. By stepwise selection, we have a backward elimination, we have a forward selection, and we have both directions. But you know what? I want to talk about, uh, you know, uh, I'm going to take one at a time. Now I need you to pay attention. In this lecture, I'm only going to focus on, I'm going to focus on backward. I'm going to focus on forward. What do I mean by backward? What do I mean by forward? I need you to pay attention now. If I want to use forward selection and I'm having three predator, please pay attention. If I'm going to use forward selection and I'm having three predator, I will start from zero. I'll start from intercept model. Okay, the forward selection, as I'm going forward, I'm actually going to be adding more, provided, uh, it now depends on the criteria I'm going to be using. I can do forward selection with AIC. I can do forward selection with BIC. I can do forward selection with adjusted R squared. So when you want to embark on forward selection or backward elimination, you need to actually tell us the criteria that you are using. Now, by forward selection, I'm actually going to start from zero. I'm going to start from intercept model, and I'm actually now going to be going up all the way to see if adding additional predator is going to be gainful or not. Does that message? Do you understand that message? If I want to talk about backward elimination, if I have three predators, I'm actually going to start with the three predators. I will start with the most complicated model with a backward elimination. I'm starting with a full model with a complicated model. I'm actually now going to be going backward to eliminate any insignificant variable out of that. And that's why it's called backward elimination. But you know what? Whether you want to do the backward elimination or you want to do the forward selection, you're actually going to tell us the criteria you're going to use. Now, I actually going to demonstrate to you right now. Okay, if you take a look at what I have, I'm actually going to start something now. For instance, I want to start with backward elimination with AIC. I can do backward elimination with BIC. I can do backward elimination with the adjusted R squared. But I want to do that with the AIC right now. What am I gonna have in my step one? I'm actually starting with the most complicated model. Here I'm having three predators. I want to go backward. I'm going to start with the most complicated model. Then I'm going to feed this model. Then I'm going to compute the AIC. The AIC here is negative 112. Okay. Now I'm going to go to the next step. Please pay attention. When I have three predators in my model, okay, what would be the next thing to do? Maybe to drop one, right? To drop one. Then I'm going to now take a look at this. I'll consider S1 and S2. in the next one, I will consider S2 and S3, and I will consider X1 and S3. Take a look at that. Then I will compute AIC for each of that. Okay. Now, when you take a look at what I have right now, I'm showing you the algorithm. Okay. Initially, this is the AIC, but right now, okay, for me to go from a complicated model, a model with a three predator to model with two predator, then I'm actually going to settle with the one that have a lower AIC. Now, right now, take a look at what I have. This negative 110. But if you take a look at the two here, these two model, okay, actually have a lower AIC compared to the complicated. Okay, negative 116 is 116. It's less than negative 112. Negative 119 is less than that. But I'm actually going to choose the most negative. Okay, please pay attention. I'm showing you the algorithm now, the way the algorithm work. So right now, okay, what I've chosen is this guy. Okay, I choose that guy because of the fact compare the IC to this guy. Of course, it's smaller, even though this guy also smaller, but we're gonna settle for the most negative. Okay, so right now, where we are now, okay, in a step two, this is the best model for now. When I have a two predator model, I also want to see whether if I drop one, that may be gainful to the model. Okay, now take a look at what I'm having now. I have X1 and S3. I'm only going to consider a model with X1 with model with S3. I'm not going to consider with model with with S2 because that S2 is not part of the where we are right now. So take a look at what we're going to have. Now you see the reason why why I actually consider the model with X1 and S3 because right now in the updated model I only have S1 and S3. I wanted to stand alone. I'm going to compute the AIC. Okay, computing the AIC. I'm actually going to compare the AIC of the simple model now with a complicated one. And which one is smaller? Of course, the one that is smaller is this guy here. Take a look at that. Okay, that is a smaller one. And of course, the next thing, now that this guy is a smaller one, okay, the model with the S3 is the best model at the moment. Then I will now start thinking again. Hmm. When I had three predator, I was able to eliminate some predator. I was able to get to two predator. When I have two predator, I was able to eliminate one. I'm right now in one predator. Can I also eliminate that one? I want to see whether I should consider model without predator at all. Considering a model without predator at all is when you're considering an intercept model. Now I consider intercept model and I look at the AIC. That was worst because the AIC of the intercept model is actually greater than the AIC of that. So which means the best model according to the stepwise, according to the backward elimination with the AIC is actually that guy. Is there any question on this algorithm, the way this algorithm work? Is there any question? Go ahead. Why do I choose what? That is the smallest AIC. If I have smallest, the most smallest is what I'm going to choose. Does that make sense? Okay, that's a good question. You know, of smallest, there's always going to be the smallest. That would be smallest among smallest. I like that question. Okay, now go ahead.
Well, just using X2 for example, right? In this example, right? You know with certainty that X2 is not better than any of the other models,
Okay.
right? Can we prove that somehow?
Okay, so that's it. That's an excellent question. Just give me 1 second. Right now, the limitation of backward elimination, because we never have opportunity to try S2 Okay. And if S2 happens to have, just like what you said, if I now find the AIC of S2, if it is lowest than the one we settle for, then this particular algorithm has missed the best model. So that is one of the limitation of backward elimination. There's possibility it missed the best model. Does that make sense? Have I answered your question? Okay. Now, by backward elimination choose this model with just one predictor S3. Now, let us now see uh what the forward is going to do. You know, we have actually done backward elimination with AIC. We now want to do forward now. With it forward, I told you, you are starting from the simplest model, intercept model. Okay, we get the AIC. Okay, after that, we go to 1111, right? Situation where you have 1 1 predator. Okay, this is the forward now. Forward is like starting from 0, getting to 1. Okay, now if you take a look at this, we want to see which of this is better than that. Okay, of course, negative 115. If I all of them better, but we're going to choose the most negative, just like what I said. So what is the most negative? Negative 125. Oh, can you see that? The person that asked question the other time, the most negative this time around, the three of them are lower than the first one. We're choosing the most negative. And after choosing the most negative, now I need you to pay attention now. If I want to consider two predator now, I'm actually going to consider two predator that has S2 only. I'm on the S2 right now. The one that have S2. Now, which we're going to have two that have S2 in that. S2 and S3 and S2 and S1. We're never going to consider, S1 and S3. Okay. So right now, you want to compare negative one one. Oh my God. If you take a look at this guy now, take a look at that guy. The two of them is actually higher than that. Okay. So because it's higher than that, so what happened now? So we're going to settle for the S2. Okay. We settle for the S2. So you see what I'm talking about? Now there's something I want us to do. Forward selection, choose X2. Backward elimination, choose S3. There's something I want and I wanted to see. Take a look at this. The AIC is negative 121 for that. But here, the AIC is negative 125. Definitely, the forward selection means the best model. That's what I'm saying? Because the best model by AIC should be X2. Can you see that? So that is what I'm talking about. There could be conflict. I don't know why there's always a conflict, between approach in life. I don't know why. There's always a conflict. But you know what? When there's a conflict, of course, we know the way out. Okay, now I think I just explained all of that. Another typical questions that's actually going to come out from here. How many modules do we consider in this backward elimination process? Let me tell you this. In the backward elimination, before we arrive at these results, okay, how many modules do we actually consider? We have a formula for both backward and the forward. To know the numbers of modules, you're actually gonna pass through before you figure out the best module. It is k, it is k plus 1. It is k plus 1. I think it is k into k plus 1 divided by 2 plus 1. Did you know that k into k plus 1 divided by 2 is a sum of natural numbers in mathematics, right? Okay, so if you plug in k to be 3, we are dealing with 3 predator, right? Put 3 where you have k, what do you have? So if I plug in 3, I'm actually gonna have 3, 4, okay, divided by 2 plus 1. What do I have? That should give me 7. But let's count. How many module? 1, 2, 3, 4, 5, 6, 7. We're always going to use 7 when we have where k equal to 3, either for backward or for forward. But let me tell you this. If you are to use off subset selection, okay, we're actually going to use 8 because all subset selection is going to be 2 raised to power 3. Does that make sense? Just wanted to take notes of that. Okay, now let me tell you this. A philosopher said, and I quote, I think his name is Robert Frost. I just wanted to take a look at what he said. He said, two roads diverge in a wood, and I took the one less traveled by, and all that has made the difference. You find yourself in maybe in a forest or maybe wood forest, and you have two divergent roads. Choosing the one that is less traveled by is to choose you know the most simplest one and the best model. And that is the essence of the stepwise regression, the essence of all subset selection. We're not going to pass through all roads, but we're going to choose one that we believe that will do the job at the end of the day. Now, what is the strength in the stepwise regression? Is computationally efficient compared to, because here you only, when I say stepwise, I'm referring to the forward and the backward, and forward selection and the backward elimination. Let me tell you this, you're actually going to save time because the numbers of models you're going to consider to arrive at the best model is fewer compared to all subset selection. The all subset selection, you're going to consider a lot of models. Don't forget, 2 raised to power, 2 raised to power the numbers of the predators that you have. But what is the weakness here? What is the weakness of the stepwise? Okay, it may miss the best model. Of course, you all saw the other time. The forward selection missed the best model. Okay, so that is the dangerous. That is the just the weakness of that. Okay, how do you do this in R? Please pay attention. How do we do all subset selection in R? Okay, the other time I walk you through all subset selection. In all subset selection, you're actually going to consider all modules, all possible modules. How do I go by this? I want to use an example of a rate my professor data set. Okay, in the rate professor data set, where maybe I want to look at I want to look at the effect of some variables on on the response. A variable like clarity of a professor, the rate of interest or the paper years or the gender. Okay. Now I got 4 predators. If I'm actually gonna use all subset selection, okay, that will be 2 raised to power 4. I actually need to consider 16 modules. And how am I gonna do it? Pay attention. This is where you're gonna do it. Number one thing you actually going to do is this. If you look at the first one, if you take a look at this guy here, okay, with one predator, I believe that, I fitted, please pay attention. Since I have 4 predators, I'm actually going to have 4 modules for one predator. I'm going to say that again. I'm actually having 4 predators. How many modules am I going to have for one predator? It's going to be 4. I'm going to have the module with clarity, with module with the other predator, making 4. I will choose the best of the 4 modules. Now, based on the AIC and the BIC, okay, this module is the best among module with one predator. I'm also going to fit model with 2 predators, 2 possible predators. Don't forget we have 4 predators. If I have 1, 2, 3, 4, I'm going to do 1, 2. Okay, 1, 2 in my predator S1 and S2 in my model, S2 and S3, S3 and they're going to be so many. And the best model according to the AIC is this guy. I'm also going to do the same among three predators. Three possible predator. The best among them is this guy. But before I arrive at the best, I have considered so many models. How many models am I going to consider in all? It's going to be 16 models. Don't forget I got four predator. Okay. And of course, this is a complicated one. Okay, that is it. I see. You now know you know what I'm gonna do now. Oh my God. I've chosen the best of one predator. I've chosen the best of two predator. I've chosen the best of three predator. I've chosen the best of course, for four predator, it's just gonna be one time. Okay. Then I want to compare the best with the best. Using the AIC again. Using the AIC again or BIC. Take a look at all of that. Take a look at all of that. Whether you want to use the BIC or the AIC, you now check the one with the smallest AIC or BIC is the best model. I'm done with the all success selection. Now, that is how to do that now. How do we do that? How do we what about the stepwise? Please pay attention. What about the stepwise? I'm actually walking you through how we do it in R. The other time I walk you through the algorithm manually, how it's actually how it works. Now I want to do backward elimination. Please pay attention. Don't forget with the backward elimination, I'm actually going to start with complicated model. Now take a look at this. I just wanted to see the code. Can you see the code right now? If you take a look at the code, you stated all the predator, clarity, radar interest, paper, and gender, the data I'm using is the rate professor. And then you're going to write step M4. Okay, the M4 is the complicated. Then in the direction, you specify whether backward or forward. Now I'm going to do backward. I indicated backward. Now, here where k equal to 2. Okay, k equal to 2 means I actually want to want to consider of course if you take a look at this, pay attention, take a look at this. If you take a look at this guy, okay, M0 and M4, the M0 is just the most simplest model, the intercept, and the M4 is the most complicated model. But you know what? At the end of the day, okay, and with the K equal to that, of course, I want to say I'm interested in AIC. And look at what the arrow automatically give me. Arrow automatically give me that. I said use the best model according to the backward elimination is when you consider clarity and the radar interest. But for the all subset selection on the same data, let me see the smallest one here. Is it this one? I think that should be the smallest, right? Most negative. Okay, the all subset selection also select that. So they're the same model. At times they can agree. Situation where all the selection criteria agree, that is actually a very strong conviction that that is the model. Where they disagree, there could be some kind of doubt. Okay, now I'm going to do the same to forward elimination. Now in the forward elimination, okay, I'm actually gonna, don't forget the forward starts with the most simplest model, M0, and that is why you see, quality on 1, okay, and you indicate forward, okay, here you're gonna be M0, and of course, you're doing the AIC, and this is what, so accidentally here, okay, the three method that we have used actually selected the same model. There is possibility that they may select a different model, but it's now a matter of choice. You all know the weakness of all subset selection. The weakness of all subset selection is very it may be tedious to go through all models because the all subset selection go through all model. But when you have the opportunity to go through all model, Of course, it's guaranteed to get the best model because it's going to go through our model. Okay, but when you take a look at the other one, it's not that computationally intensive. We talk about the stepwise approach that we call the backward and the selection and the forward selection. Of course, that has a tendency of actually miss out on the best model. What are we going to have next? Of course, what we're going to have next is to go through the other material. I think the material for the week have already been uploaded. Is there any question for me before I go today? You say what? Okay. What is the K meaning? Let me quickly do this. That's a good question. I'm actually going to, when you talk about K, of course, K is the number of predator. Okay, and there's something I quickly want to show you. 1 second, I'm gonna share this now. Okay, okay. Now I'm gonna go back. Just wanted to see something so that you see the difference between uh okay AIC and BIC, the way to specify in terms of K. Okay, now here. Oh no, not this one. Okay, you see 2K. Okay, I want to take note of something. This part is going to be the same for BIC as well. But in the case of BIC, K is going to be log of N. Now you're going to see something now. Do you see that? Do you see log N? Now, that very log N, if log N equal to 2, if log N equal to 2, you have AIC. Do you see that? So the difference between AIC and BIC is for BIC, that very 2 will be replaced with log N. But in the AIC, you're just going to have 2K. Does that make sense? But K is the numbers of predators or the numbers of regressors, depending on whether you're talking about adding, maybe you have a cubic or quadratic term or whatever, but just take it as the numbers of predators. Have I answered your question? Okay. That is all what I got. Be sure you all stay safe and have a lovely day. Bye.